Hello everyone, welcome to my channel C.S.E-Pathshala. In this tutorial of Introduction to Deep Learning, we will study about multi-layer perceptron. We have already discussed in our previous tutorials that networks keeps very much importance as they are very much helpful in solving various challenging artificial intelligence problems. And basically, their functioning is much more better than traditional machine learning algorithms or techniques because they are advantageous with respect to non-linearity, variable interactions, and customizability. The process of creating a neural network begins with the perceptron. And if we talk about the perceptron, it receives inputs, then multiply with some weights, and whatever the result comes, then it passes to the activation function. And activation function could be like logistic, relu, tanh, or identity. And ultimately, the result has been given to produce the output. Okay, so it's already a layered structure. We have discussed that in case of deep learning, we are having an input layer where we used to give the inputs, and then uh, in your hidden layer the computation is being performed, and then whatever the output comes, it's been given to your output layer. Okay, so that's a basic architecture of neural networks. Now if we talk about neural network and addition of the layers for the perceptrons, it becomes a multi-layer perceptron mode. Okay, and therefore it's called as a multi-layer perceptron. Okay, so as known or discussed that there are three layers for the neural network, that is input layer, hidden layer, and output layers. And this is what happens at the input layer, that it receives the data, and output layer is used to gives the output which has been created by the computation on the hidden layers. Okay, and obviously the hidden layers, these are the intermediate layers which performs all the computations. So a neural network algorithm, basically it performs all kind of problems solutions. Okay, that means it can have a classification, also it can do regression also. And in case of MLP classifier, that is multi-layer perceptron classifier, as its name itself suggests that it basically connects a neural network. Okay, so now here, if we talk about the classification problems, such as being solved by the traditional machine learning algorithms, for example, support vector or naive Bayes or MLP or whatsoever, it can also be done, or it can also be solved with the help of a neural network also. On the similarity, though, with the help of a scikit-learn, other classification algorithms, which we have seen with your machine learning also, the same thing here in neural network, MLP classifier, it also takes no additional or hard efforts for the implementation. If we compare it with the support vector machine, or if we compare it with the naive Bayes, or if we talk about decision trees, or if we talk about random forest, any of the classification algorithms which can be taken from the scikit-learn library, MLP classifier also performs the best classification. Okay, if we just compare with these traditional machine algorithms. So let us consider an implementation related to it. Here we are having a problem statement for which we are designing a Python layer, multiple layer perceptron using scikit-learn library. Two inputs are given to it, and one output we are producing, and the task which we need to perform is the logical AND operation. Okay, so here we are using a scikit-learn library to perform this task. Okay, so let's get started. From sklearn.neural underscore network, import MLP classifier. So in our sklearn library, from neural network, we are already available with MLP classifier, that is multi-layer perceptron classifier. Okay, so scikit-learn, it's comprises of all such algorithms. Okay, neural network algorithm is also, all the neural network algorithms are present in it, and from there we are accessing one library, that is MLP classifier. Then the next thing is here we need to give the two inputs. So the two inputs are in the form of 0 and 1. Okay, so the combination of 0 and 1 here we are taking like this: 0 0, okay, then 1 1, then 0 1, and 1 0. Okay, so here is the combination of both the bits. As we are performing the logical AND operation, so the output will be like this. For 0 0, the output will be 0. For 1 1, the output will be 1. Obviously, it's an AND operation. So for 0 1, the output will be 0. And for 1 0, the output will be 0. Okay, now the next thing is we need to use MLP classifier. So from this MLP classifier library, we are taking, or either whatever you can say, from this class, we are taking this method, or we can say that it's a constructor to this particular class. Okay, so MLP classifier, we are taking this classifier, or rather you can say it's a model or whatsoever. MLP classifier, there are some parameters which can be given to this method, and these are the following parameters which I am taking to perform the classification. The first one is a solver. Here I am taking LBFGS. So if we refer to the official website of Scikit-Learn for MLP classifier, here are the parameters given for it, and the parameter which we are taking here is a solver. Okay, so the solver is used to perform the weight optimization. Okay, so ultimately it's an optimizer, and there are various optimizer which are present here. For example, LBFGS, SGD, and ADAM. Okay, so I'm taking LBFGS optimizer, which is an optimizer in the family of quasi-Newton methods. Okay, so what is this LBFGS? It stands for Limited Memory Broaden Fletcher Goldfrapp Shannon. Okay, it approximates a second derivative matrix and updates the gradient evaluation. Obviously, as we know from here that it's been an optimization technique. Okay, so here it approximates the second derivative matrix. It stores only the last few updates or the values, and all have been saved into the memory. It is fast in nature for the larger data sets, and it can be like a default solver for scikit-learn versions 0.22. Okay, so here I'm taking this solver or optimizer LBFGS. The next is alpha 1e minus 5. So what does this alpha means? See, alpha basically it's an LTU regularization term, and this L2 regularization term is divided by the sample size when added to the loss. Okay, so what does this basically means? See, it's a parameter which is used to control the overfitting and underfitting of the model. Okay, and here we have taken alpha as an exponential notation. So exponential notation 1e minus 5, this basically means 1 into 10 to the power minus 5, or it can also be further solved as into decimal points like 0.00001. This is the value of alpha which I have been taking here, and it's to control the overfitting and underfitting of the overfitting and underfitting of the models. Okay. The next parameter which I am going to take here is the hidden layer sizes. Okay, hidden layer sizes. So the hidden layer sizes which I have taken in this example is 5 2. So it means the hidden layers. Okay, 5 comma 2 means we are having two hidden layers. In first hidden layer, I am having 5 neurons. In the second hidden layer, I am having 2 neurons. Okay, so this is very simple to understand. As per the definition, the parameter of hidden layer is set the number of layers and the number of nodes we wish to have in a neural network classifier. Okay, so here basically we are having two layers. Okay, and each layer comprises of as much of nodes which you have mentioned. Okay, so in the first hidden layer, I'm having five nodes, 5 neurons, and in the second hidden layer, I'm having 2 neurons or your two nodes. Okay, and the last one is your random state. Okay, so the random state is just a number that determines the generation of weights and the bias initialization. And training test is split. If we are using early stopping, okay, and batch sampling. Okay, so we need to assign a random number during this process, during the weights and the bias initialization, during training test splitting. Okay, and when we are using this kind of solvers or your optimizers, SGD, Adam, or we are using the optimizer like LBFGS. Okay, so it produces an integer value. Okay, it passes an integer value that results across a multiple function calls. So whatever with the function calls, so we used to give this integer value. So here I'm taking integer value random state equal to 1. The next thing is I'm fitting the value of x and y. Okay, here is the x and here is the y. Okay, so I'm fitting the values of x and y in my model. I've already defined my model here above. Okay, each and every parameter I have discussed. Okay, so fitting the data into my model, and after my model has been trained, okay, then you can give any random samples to perform the prediction. For example, here I've given 1 and minus 2, so let's check what is the output. So let me run the code. Here the output is 0. Okay, and you can take any of the value. For example, I take 1, 2. Okay, so here the output is 1. Okay, so my model has been trained accordingly for the respectively given values. Now the point is, if I need to improve the hidden layer sizes, for example, in the next case, I have taken 3 hidden layers, and each and every hidden layer I am taking 100 neurons or 100 nodes. Okay, so ultimately I want to train my model much more better. Okay, so let me run this code again. Fine. Here the output is 1 for the input 1 1. Okay, so let me change the input like for example 1 minus 3. Okay, so what is the output? Okay, the output is 0. Let me change my input as minus 1 minus 3. So what is the output? 0. Okay, so the point is clear that if we give positive samples, okay, so the output is 1. And if we give the negative samples, the output is 0. Okay, for the logical AND operation. Now, if you want to perform logical OR operation, okay, so here in this code, I have performed logical OR operation. So what could be the input? So input will be for the two only, okay, for the two inputs only, 0 0 1 1 0 1 and 1 0. This is the combination, and the output which we are getting according to the logical OR operation, that is 0, okay, for 0 0, and 1 for 1 1, 0 1 for 1 we are getting the output, and 1 0 here the output we are getting as well. Okay, so this is obviously logical OR operation. Again, I am taking the same thing, MLP classifier. All the parameters are same. Only one thing is I am again taking the hidden layer sizes as 100 100 100. That means I am taking 3 hidden layers, and on each hidden layer I am taking your 100 neurons or the 100 nodes. Okay, again I'm fitting the data into the model and performing the prediction. Okay, so here I'm taking the input as 0, 1. Okay, so the output is your 1. Okay, and if I take, for example, 1, 1. Okay, so the output is again 1. If I take 1, 5. Okay, any sample, any random sample I can take, it's 1. Okay, and if I take minus 1 5, let's see what is the output. So it's again 1. Okay, and let me take like minus 1 and minus 2. Okay, so if both the values are negative, the output is 0. If anyone is negative, or then another is positive, then the output is obviously 1. So here the model which got trained is just taking the values. For example, if it has been negative, then it is assigning it to 0. Okay, only one value is negative, then it's assigning it to 0. Another one is also negative, then it's again 0. So 0 0, accordingly what the model has trained, the output should be 0. If any one is negative and another one is positive, then it will be like 0 1. Okay, so it's giving you the output as 1. And if both are your positive, so obviously the result is positive. If any one is positive, okay, so the result is your positive. Okay, so for example, minus 1 2, The output is 1. Okay, so this is how we train our multi-layer perceptron classifier. There are other functions also which are available in this classifier. Okay, so we are going to see them ahead in our upcoming tutorials. Thanks for watching. Do subscribe to my channel.